The Pacific Ocean, the largest on the planet, reveals a landscape of striking contrasts. Calm waters on the surface conceal a dynamic and unpredictable world. Across its vast expanse, archipelagos, powerful currents, and deep abysses form the backdrop of an environment in constant transformation. Between waves and reefs, a multitude of species find shelter, sustenance, and daily challenges. Dolphins surge in pods, slicing the surface with synchronized leaps. On the seafloor, starfish rest like scattered jewels in a mineral silence. Nature's drama here reveals itself in every detail, from the swift strike of predators to the delicate balance between microscopic prey and colossal giants. The atmosphere is charged with suspense and vital energy. Nothing is predictable in this liquid universe. Every current, every shadow carries the promise of discovery and the risk of confrontation. The Pacific is both stage and protagonist of survival stories that impress with their scale and intensity. Dolphins stand among the most iconic images of the Pacific Ocean. With streamlined bodies reaching up to 11 feet in length and weighing over 550 pounds, they glide through the waters at speeds above 25 miles per hour. Their smooth skin reduces drag, while social intelligence enables life in organized groups, known as pods. These groups serve not only to hunt more efficiently, but also to protect the young or injured. Their synchronized leaps above the surface mark both hunting moments and social interactions. Each dolphin produces a signature whistle unique to the individual, functioning as an acoustic ID that ensures communication amid the constant noise of ocean currents. Deeper down, where light filters gently, starfish rest on rocks and reefs. With varied geometric shapes and vibrant colors, they resemble natural sculptures. Despite their fragile appearance, they are patient predators, everting their stomachs to digest prey such as mollusks and small crustaceans. Able to regenerate lost arms, they stand as symbols of resilience in the marine world. Coral reefs, in turn, function as fortresses of life. Limestone structures built over centuries house colonies of fish, crustaceans, and microscopic algae. Within them, diversity is nearly unimaginable. An estimated 25% of all marine species depend on this habitat at some point in their life cycle. Reefs provide shelter from predators, breeding grounds, and abundant food resources. In the same environment, millions of invertebrates thrive. From filter-feeding sponges to tiny cephalopods, each occupies a vital niche. They purify the water, recycle organic matter, and serve as food for larger fish. Together, they form the quiet foundation of complex food webs. The ecological role of this system is clear, maintaining balance. Dolphins regulate fish schools, starfish prevent mollusk overpopulation, and invertebrates recycle nutrients. It is a natural mechanism of stability that sustains both top predators and invisible microorganisms. Yet, changes in water temperature and acidity are already disrupting parts of this system, weakening reefs and reducing the abundance of certain populations. While dolphins patrol the surface and reefs rise like submerged fortresses, in open waters emerge predators that dominate through strength and strategy. This is the realm of sharks and killer whales, hunters that challenge the very logic of survival. Sharks are symbols of predatory efficiency in the Pacific Ocean. Among them, species like tiger sharks and mako sharks stand out, capable of reaching remarkable speeds in short bursts. With elongated bodies, skin covered by dermal denticles, and highly developed sensory systems, they detect even the faintest electrical impulses from their prey. Their jaws, armed with rows of sharp, replaceable teeth, allow devastating attacks. In a single strike, they can tear away large chunks of flesh, commanding respect across the ecosystem. This combination of speed, powerful bite, and near panoramic vision ensures their place as relentless hunters. If sharks embody brute force and instinct, killer whales symbolize intelligence and strategy. Measuring up to 30 feet and weighing about 6 tons, these cetaceans live in stable family groups called pods. Their communication involves a complex range of sounds, used to coordinate movements and teach tactics to calves. Collaboration is the key to success. Killer whales herd fish into tight clusters, disrupt schools, and then strike efficiently. Their hunting repertoire is bold and varied. Along parts of Patagonia, they deliberately beach themselves to snatch sea lions off the sand, risking their own bodies in maneuvers requiring pinpoint precision. In other cases, they even challenge giants like whale sharks, attacking them only for the liver, rich in energy, and leaving the rest behind. This selective feeding demonstrates not just adaptation, but the ability to innovate when opportunities arise. Among the most dramatic encounters are direct clashes with sharks. Killer whales use specialized techniques, flipping sharks upside down, inducing a paralysis-like state known as tonic immobility. In this way, they neutralize feared predators and reaffirm their absolute dominance over the ocean. This behavior reinforces their role as apex superpredators, creatures capable of overpowering even the most feared individual hunters. The balance between sharks and killer whales shapes the dynamics of the Pacific. One represents individual power, the other collective intelligence. Together, they keep fish and marine mammal populations in check, preventing ecological collapse. This ongoing contest between instinct and strategy composes the natural drama of the open sea. In the vast Pacific stage, the food chain is a multi-layered mechanism. At the very top stand two apex predators that shape the marine balance, the killer whale and the great white shark. Though both are exceptional hunters, their dominance over the ocean reveals fundamental contrasts. Killer whales, living in cohesive pods, represent the height of collective power. Their strength lies not only in size, but in organization. A single family can alter the behavior of entire communities of marine mammals. Seals change migration routes, dolphins avoid certain areas, and even large sharks abandon territories when killer whales appear. The mere arrival of a pod reorganizes space, creating exclusion zones that reshape local dynamics. The great white shark, by contrast, holds its role as a solitary predator. Its function in the food chain is to regulate mid-level populations, especially sea lions and large fish. When a great white shark approaches, prey behavior changes instantly. Seals linger in shallow waters, fish schools scatter, diving birds avoid deeper areas. This indirect effect, known as the landscape of fear, shows how the presence of just one individual can reshape ecosystems. When these two forces meet, the hierarchy is clear. The killer whale, with its strategic intelligence and cooperative strength, overpowers the great white shark's solitary might. Scientific records show that after killer whales prey on great whites, local shark populations abandon the area for months, breaking food chains that once held balance. This absence triggers cascading effects. Mid-level prey increase in number, impacting sardine schools and even coral reef communities. Thus, it is not merely a clash of giants, but a natural mechanism that defines who controls the flow of energy in the ocean. The The great white shark is the pinnacle of solitary hunting. The killer whale, the true architect of the Pacific, dictates marine order. While the open seas witness disputes between apex predators, in the shallow reefs another spectacle unfolds. A microscopic and vibrant universe where clownfish and sea anemones form survival alliances in a dazzling world of color. In the reefs of the Pacific, life organizes itself in complex networks of cooperation. Among the most fascinating is the symbiotic relationship between clownfish and anemones. Small, averaging 4 inches in length, these fish display bright orange, white, and black colors that contrast with their surroundings. Their robust bodies and rounded fins provide agility in coral-dense areas. Their flashy colors, which could make them vulnerable, are safeguarded by the lethal protection of anemones. Anemones possess tentacles lined with stinging cells capable of paralyzing unsuspecting fish. Clownfish, however, develop a special mucus layer on their skin that renders them immune. This adaptation allows them to live among the tentacles, finding refuge from predators while simultaneously attracting prey that the anemone consumes. The result is a partnership in which both benefit: protection for the clownfish, nutrients for the anemone. The social dynamics of clownfish are equally unique. All individuals are born male, but the dominant one can change into a female if hierarchy shifts. This system ensures group continuity and allows quick adaptation to environmental changes. Organized colonies always feature a primary breeding pair, while the rest remains subordinate. This structure reduces internal conflict and increases survival chances. Clownfish also play an important ecological role in maintaining balance. By drawing smaller predators toward anemones, they help control populations of organisms that might otherwise destabilize coral communities. Their constant activity also stimulates nutrient circulation between corals and symbiotic algae. Coral reefs as a whole play a monumental ecological role. Though they occupy less than 1% of the ocean's surface, they shelter about 1/4 of all known marine species. They are nurseries for life, where larvae find refuge and feeding grounds for larger predators. Yet these ecosystems face a growing threat: coral bleaching caused by rising ocean temperatures. This process weakens the very structure that supports thousands of species, threatening the stability of the entire system. While reef life reveals cooperation on a small scale, in the depths the scene shifts dramatically. There, silent giants like sperm whales dive more than 3,000 feet in search of colossal prey, waging epic battles against giant squid in the heart of the abyss. In the deepest regions of the Pacific Ocean, where sunlight never reaches and crushing pressure challenges any unprepared body, lives one of the planet's largest toothed predators, the sperm whale. This colossus can reach 50 to 65 feet in length and weigh up to 80,000 pounds. Its massive head, accounting for a third of its body, contains the spermaceti organ, believed to aid in buoyancy and the emission of low-frequency sounds for navigation and communication. The sperm whale specializes in extreme dives. It can remain submerged for over 90 minutes and reach depths greater than 3,000 feet. To survive, its body adapts by slowing its heartbeat and directing oxygen only to vital organs. Its secret weapon is echolocation, a biological sonar system that emits powerful clicks, bouncing back detailed information about its surroundings. With this skill, the sperm whale hunts its most iconic prey, the giant squid. These cephalopods, reaching over 40 feet in length, are formidable adversaries. Armed with tentacles lined with suckers and hooks, they resist fiercely. Circular scars, often found on sperm whales' skin, testify to epic battles fought in the abyss. Each encounter is a duel of brute strength versus agile tentacles, a silent clash rarely witnessed by humans. In the food chain, sperm whales play a vital role. By preying on giant squid and other deep-sea species, they regulate populations that might otherwise grow unchecked. Moreover, their iron-rich waste fertilizes phytoplankton near the surface, linking deep-sea ecosystems to surface productivity. It is a cycle that keeps the ocean functional, even in seemingly isolated regions. Few natural predators challenge adult sperm whales, though calves can fall prey to killer whales. Even so, their longevity, living more than 70 years, ensures a lasting presence in marine ecosystems. While the abyss harbors battles between unseen titans, in tropical and coastal waters, another ancient traveler crosses great distances, the hawksbill sea turtle, navigating thousands of miles on journeys that span generations. Among the most emblematic species of the Pacific The hawksbill sea turtle stands out for its ability to travel vast distances on migrations exceeding 1,800 miles. With a serrated, elongated shell that can reach 3 feet in length and weigh nearly 180 pounds. Its streamlined shape is ideal for crossing ocean currents. Its curved, sharp beak allows it to access the crevices of coral reefs, feeding mainly on sponges and invertebrates. This marine reptile possesses a unique navigational mechanism, magnetic philopatry. Thanks to receptors sensitive to the Earth's magnetic field, it can pinpoint the very beach where it was born, returning decades later to nest. The reproductive cycle is intense. Each female may lay up to 160 eggs per clutch, buried in the sand under cover of night. Yet survival is brutally selective. Only about 1 in 1,000 hatchlings will reach adulthood. Defense strategies begin early. Hatchlings dash toward the sea under the constant threat of seabirds and crabs. In the ocean, larger predators like sharks and killer whales remain a danger. Their hard shells and tendency to stay in shallow waters offer partial protection, but not immunity. Still, the species' longevity, surpassing 50 years, ensures population continuity. In the ecosystem, hawksbill turtles play a vital role in regulating reefs. By feeding on sponges, they prevent these organisms from overwhelming corals. In doing so, they act as agents of balance, sustaining marine diversity. Their nesting behavior also enriches coastal soils with nutrients, indirectly linking land and sea. For centuries, the species endured human exploitation, both for eggs and for shells used in crafts. Though protective measures have curbed much of this, hawksbills still suffer from long-term impacts, such as accidental capture in fishing nets and shifting ocean currents. While turtles cross oceans on endless journeys in rocky zones and coral reefs, another master of adaptation hides in plain sight. The octopus, capable of changing color, texture, and behavior within seconds, transforming into a living illusion of the sea itself. In rocky crevices and reef hideouts of the Pacific, the octopus reigns as a specialist in adaptation. With a soft, boneless body, it squeezes through the tiniest gaps. Any opening larger than its beak can be enough to escape predators or reach prey. Using muscular arms and sensitive suckers, it manipulates objects opens shells and explores with dexterity rivaling that of primates. Its most astonishing ability is camouflage. Specialized skin cells called chromatophores allow instant changes in color and pattern, mimicking rocks, corals, or even sandy textures. This strategy not only confuses predators, but also aids in ambushing unsuspecting prey. When camouflage fails, the octopus releases a cloud of ink, creating a dark curtain to disorient attackers and slip away. In hunting, the octopus shows remarkable intelligence. It may lie in wait for a fish to approach or pounce with speed, wrapping prey in its arms. Its hard, sharp beak pierces crustacean shells and tough exoskeletons. Species like the blue tang, popularly known as dory, are sometimes among its victims, caught by the precision of this silent predator. Octopus behavior goes beyond survival. Studies show problem-solving skills, tool use, and even escape artistry from aquariums. This cognitive complexity reinforces its status as one of the most extraordinary invertebrates on Earth. In the ecological balance, octopuses regulate mid-level populations. They feed on crustaceans and small fish, but are themselves prey for sharks, killer whales, and even seabirds. This intermediate role ensures the flow of energy between different levels of the food web. Few animals combine such versatility of body and mind. With every color shift and fluid movement, the octopus reaffirms camouflage as an art of survival. And so, from the brilliance of reefs to the darkness of the abyss, the Pacific Ocean reveals itself through countless forms of life, connected by invisible relationships that sustain the balance of the largest ocean on Earth. The Pacific Ocean, the largest body of water on the planet, is more than an immense blue surface. It is an interconnected system sustaining life on multiple scales. From dolphins dancing in pods to starfish resting on reefs, every organism plays a specific role in maintaining balance. Apex predators, such as sharks and killer whales, shape the behavior and distribution of other species, while deep-sea giants like sperm whales link unseen depths to surface productivity. Hawksbill turtles travel ancient routes, bridging distant seas, and octopuses showcase the ingenuity of camouflage in challenging environments. This mosaic of interactions shows that the Pacific is not just a habitat, but also a climate regulator and a source of essential resources for the entire biosphere. Its biodiversity guarantees stability, productivity, and resilience in the face of environmental change. Yet, human pressures and climate shifts already pose significant challenges, weakening reefs and altering migratory routes. Conservation efforts, from marine protected areas to monitoring key populations, are crucial to ensuring these ecosystems remain functional. To protect the Pacific is to safeguard not only the survival of the species within it, but also the future of human societies that depend on its ecological services. Preserving this ocean means preserving Earth's greatest reservoir of life. The future of biodiversity, and to a large extent our own future, is inseparably tied to the balance that pulses beneath the waves of the Pacific.